Hello, my name is Mr. Mincer. I'm a student at Colorado State University at Pueblo, and this is my project for a sixth grade science classroom in a earth science class in regards to matter. Today, I want my students to be able to identify various parts of an atom while using a model, an activity in a worksheet, and how those particles change via temperature, heat, and most importantly, what is matter. So let's get started. At the end of this lesson, they'll be able to also identify three major parts of the atom and how those particles interact with heat and temperature. Students want a mixture of learning styles, and I want to provide that with this lesson. I want to provide visual and auditory and kinesthetic. I want kids to be able to get up and get them moving around. So, for the first matters, let's talk about solids. Solids are very dense particles. They're very close together, they're slow moving, and they're connected, but they cannot move freely, such as this computer, this desk, and other things along that nature. The next of the matters is liquids. Liquids are the less dense than solids. The particles are moving slightly faster than solids. They're still connected, yet they can move freely, such as water or coffee, things like those things along that nature. Gases. This is the last but not least. These are the least dense of the three. They are very fast moving particles. They try not to be contained. That's why, air exists. Particles are very far apart, not connected. For my next topic, I'm going to talk about what affects density. Well, temperature affects density, and we'll get into what temperature is here in a little bit. The hotter the temperatures, the less dense the particles are. The cooler the temperatures, the more dense the particles are. We all accidentally might have left a can of pop or soda in the freezer overnight, and when you wake up, you check the freezer and you notice, oh man, the can's swollen. That's because the particles are more dense, causing the metal to expand. So for the star of the show, let's talk about what is matter. Matter is anything that takes up space and has mass. So let's figure that out. Is water matter? Tasted like matter. So let's dissect this by the definition. Matter is anything that takes up space and has mass. Well, this water bottle is heavy. So yeah, besides the plastic, I can feel the water in there that moving around. That's the weight. So yeah, it has mass and it's also taking up space. So yes, water is mass. Or excuse me, water is matter. Is air matter? Smells like matter. So yeah, it is matter. Matter has anything that takes up space. It's taking up space here in this room. Even though we might not feel like it still is. Matter can be very large and it can also be very microscopic. So what is matter made out of? Matter is made out of protons, neutrons, and electrons. And in the middle they form the nucleus between the protons and neutrons. Protons are the positively charged protons are the positively charged particles. Electrons are the negatively charged particles, and the neutrons are the neutrally or no charge particles. Like I said, the protons and the neutrons meld together to form the nucleus. The electrons orbit around the nucleus and orbitals. Electrons are responsible for electricity. Atoms make up every living thing we see and also non-living. For my next topic, we're going to talk about phase changes. There are three common phases of matter here on Earth: solids, liquids, and gases. Temperature is required in order for these phases to change. Without phase changes, we wouldn't have seasons, and life wouldn't occur on Earth. So what happens when a liquid becomes a gas? So we have to heat a liquid up in order for it to become a gas. And that's because if you take a pot of water and you have to boil that to make pasta, you're heating up that liquid, and when you see that steam, that's becoming gas. So when does a gas become a liquid? If you take a cold beverage on a hot day and sit it on a patio, you'll notice moments later that there are water driplets forming on the outside. That's because it's cooling its surroundings. It's cooling the gas and forming liquid. And what happens when a solid becomes a liquid? Well, we've all melted cheese or chocolate for various meals or treats. So when you take a solid and you melt it down, you need a heat source. So you heat a solid. All the energy on Earth comes from the sun. The sun allows life to occur on Earth. If it wasn't for the sun and phase changes, ice wouldn't float on top of lakes or ponds, and that'd be detrimental for water wildlife. The sun also gives us vital heat and light. So let's go back to temperature. Temperature is the measure of average energy of molecular movement of a substance. However, heat is the total energy of molecular motion. Heat causes these particles to move faster and faster. The size of the container, number of particles, and types of particles, water, lead, calcium, etc., are important. Heat is the transfer of one object to another. Temperature is not energy. However, heat is energy. Temperature is the measurement of energy. Heat always transfers from a hot source to a cold source, and this is because of the second law of thermodynamics. This is also why a snowball melts in your hand instead of staying cold. Now for an activity. I want to pair up everyone into groups of 3. Each student will have a sign with a positive, a negative, or a circle. The positive sign is for the proton, the negative sign is for the electron, and the 0 is for the neutron. The proton and the neutron will stay together in the nucleus, and the electron will orbit. This will give the students a physical sense of what they are doing and how electrons, protons, and neutrons exist in atoms. This was my lesson plan for a 6th grade science class. I hope you enjoyed it.